Right, I didn't think I'd need applause for at least that bit. So, that's what I'm going to talk about. I'm not going to read through that. So, first of all, people often ask, why do this? And the first obvious answer is, it seemed like a good idea at the time. But we've heard people talk about the interest in mobile and the explosion in mobile, and everything is moving to mobile. And in some degree, the things I'm interested in start at mobile and go down. So the next 100 billion devices that get connected to the web won't be mobiles. There'll be things below mobiles. And there's such an enormous interest in machine-to-machine and cloud-to-machine applications. And I think somebody else mentioned, everything that has a CPU will be a connected device. And these devices, as they become more embedded, they will simultaneously be clients and servers. Okay, so the things that we traditionally used to write servers won't apply, and the things we traditionally use just to write clients won't apply. So for me, Node was an interesting thing to port to embedded devices because it fits that role so well. It is an environment where you simultaneously can do clients and servers. Also, we've traditionally thought of deeply embedded devices as being things that are fixed, they're frozen. Your utility meter gets installed, it stays in your house for 20 years, and it never ever changes. And until recently, phones were like that as well. They shipped with a software that was embedded at the time they were manufactured, and nothing ever changed. But as soon as they become more connected devices, then it won't make any sense to have a machine whose software was frozen 20 years ago, or even 2 years ago. So, unlike before, I think the irony is the more embedded you get, that means the longer the installed life of the equipment, then in fact the greater the incentive for it to be a programmable device. Hang on a minute. Sorry about this. Okay, so embedded will drive increasing adoption of frameworks that let you write things that simultaneously clients and servers, and more of these things will be connected, and they have to be programmable devices. So, okay, so if that's the target, why Android? Well, obviously Android, we all know now, 50% of the smartphones in the world are based on Android. Increasingly, it's going to be used in TVs, it's going to be used in cars, all sorts of other utility devices. It's an interesting place to start. There's a lot of people doing stuff on Arduino and Raspberry Pi and these things. Android is a very interesting place to start because phones have got such an interesting range of sensors and ancillary devices attached to them. So you can write a program, you can put it on your phone, and you can be talking to accelerometers and radios and GPS units and this kind of thing. Android is also still, I think, the most accessible embedded development platform. So we've seen Symbian OS and all these other things, but Android really was a huge step forward in terms of how easy it was for a developer to get the tools and be really productive writing apps. Also, this Android work has been funded by a European project called Webinos, and since they've paid for the work, I have to say something about them. Webinos, the easiest way to understand it is to think of it as the DLNA for personal data. Okay, so you have a whole bunch of personal devices. Somebody earlier today mentioned synchronization between devices, these master-master scenarios. You have devices that all have different kinds of personal data on, and they want to exchange data, and it's not simply a matter of connecting them, and it's also not simply a matter of inventing protocols where you can exchange data. It's also you have to think about how do I grant permission, or how do I write a policy whereby I know which of my devices is able to share which of my personal data, with which other applications and with which other users. So it's a system for setting up, for enabling the exchange of these services, but also setting up the policies and permissions whereby a user could configure those things. WebInOS targets not just phones, it targets cars and TVs and other embedded devices. Samsung and BMW are important partners working on the project, and I'm not going to say too much more about that, but there is a link at the end of the talk, and I would encourage you to go and have a look at that. So, let's see if I can fit these on here. There we go. So what happened when I tried to put Node on Android? Well, first of all, Node can't simply run as an executable. The reason for that is if you want it to run on a regular phone that's not a rooted phone, it has to be a Java app. So the whole thing has to be, in effect, built as a library and then integrated as a Java app so you can deploy it to the phone that's not rooted. But also so that you can, when you are running in JavaScript, you can call into the platform to do useful stuff. So the first thing I did was write an Android app. I took the Node source code, not just built it for Android, but rebuilt things so it built as a library. All of the V8 threads, the threads that execute in JavaScript, then are also attached to the Java virtual machine so they can do useful things in Java. Anyone who's been following the Node mailing list recently will know that isolates is everyone's favorite topic. And the requirement for isolates comes up for a very particular reason on Android. So the way Android works is for any given application, what Android calls an application is either a service or an application, it only permits a single process to exist at a time. So what we wanted to do with Node, though, is to be able to have multiple Node services and servers running at any given time. And for that, then, we needed to be able to create multiple Node instances within a single process. So I started this work nearly a year ago, and at that time Node was still on 0.5. There wasn't really any talk of isolates at all in the development being done by the core team. So I thought, well, how hard can it be? So I took Android and refactored things, the Node source refactored things on Android so that every single Node instance runs in a V8 isolate. Various things then can be shared between isolates. So there's a thread pool that Node uses for any blocking I/O you have to do in Node 0.6. That's managed by libuv. So that thing is shared between isolates. But there's quite a lot of refactoring to do to share what was previously singleton data, if you like, but to share some of it between isolates, but make sure that most of the data was only isolate wide. What this means now is if you do child process.fork, you can spawn a thread in the same process instead of a separate process. So that work was done at the back end of last year. And the isolates feature, as you probably know, begun to be incorporated into 0.7, and then it wasn't anymore. But it's, so I agree with the decision the Node core team made not to include isolates in the main development branch, but nonetheless there is an important reason for it to exist for Android. I should say that the work I did is still stuck at 0.6.3, so I stopped moving it forward when I thought all of this was going to go into 0.7, and then when it didn't, it basically left me a bit high and dry. So I'm starting a process very soon of moving this feature into 0.8. So the next, okay, so we've got Node. We can run as many instances we like. We get the Node API, so you can read files, you can open network connections, you can serve WebSockets, or you can serve HTTP. That's all very well, or would be useful if you had some useful information to serve over those channels. And so the next thing you need to do is, what you want to be able to do really is you want to be able to call into the platform to get to all these sensors I talked about in the beginning. Now the difficulty on Android is you can't just write a native module to do those things. So if you're on a regular Linux device, you get your C compiler out, you'd write a regular Node add-on in native code, and you call down to the GPS or whatever it is, and you could package that as a Node module. On Android, the reason we're unable to do that is because the frameworks that govern access to those subsystems are themselves written in Java. So you can't just get at it from the C level. You have to be running, you have to be able to call the Java API, so you have to be attached to the VM, which is why we needed to run in this, this Java process. You have to have an Android context. But it also means that when you leave JavaScript and enter the platform, you want to be running Java code, not native C code. And in some ways, what we do is a little bit similar to what PhoneGap does. But I created an add-on, which is a single native Node module, which will then wrap any Java library you create and present it as a JavaScript library. So I'll show an example of this. Declare any API you want to be available from Java. So declare it as an interface or an abstract class. You have to create an implementation of that, obviously, but you can load the library that implements that with this bridge module, and then it will map Java into JavaScript. You get the strongly typed interfaces that you declared in Java being presented to JavaScript, so the system knows if you call a method that doesn't exist. Performs conversion and marshalling of arguments in both directions, and it supports async event delivery as well. So obviously, when you call down into Java to perform some operation, let's say you want to read the GPS, typically that's going to be a blocking operation in Java. Sorry about this. Typically that's going to be a blocking operation in Java. You can't block in JavaScript, we know, so Java will schedule an operation, and then at the time that operation completes, you'll get your asynchronous callback into Java, into JavaScript. And if you're familiar with WebIDL, then really the way to think of it is it is a WebIDL binding for Java. And I'll show an example of that in a minute. So some words on compatibility. So anything that you've written, pure JavaScript, almost any module that's pure JavaScript from NPM will more or less just work. The kinds of problems you run into, people make hard-code assumptions about paths. They make hard-code assumptions about knowing what directory they're working in. They make hard-coded assumptions about being able to spawn native executables. None of those things are going to work in an embedded setting, but more or less everything works. Native modules, so a lot of native modules written for Linux will just port fairly easily to Android. WAF, which nobody uses anymore, thankfully, but JIP is not supported, so it means you have to write a makefile by hand to compile it for Android. But essentially, a lot of those things, assuming the APIs are there in Android, which is mostly true, they will work, and we have a lot of stuff that's running that people have just ported across from Linux. The biggest problems you've got are where people have not anticipated, not unreasonably, but they've not anticipated that the module is going to run in an environment where there are multiple isolates. So they do the typical thing where they've got a handle, say some persistent handle to a JavaScript object, and they keep a pointer to that in their statics of their module somewhere, and that just won't work in the isolate case, because the second time you run an isolate, it's just not going to work. You'll have a handle to an object that doesn't exist in your environment. And also, there's quite a lot of resource lifecycle issues. In Node, typically you run Node, it exits, and the operating system takes care of cleaning up all open files, open sockets, all this kind of thing. Although strictly speaking, you should close them down from within JavaScript, people don't. And if they intended to but forgot, they often won't notice because it all just gets taken care of by the operating system. So as soon as you're running multiple isolates in the same process, you have to start worrying about these things a lot more. So you find those kinds of bugs in other people's code show up. You get a few library shortfalls in Android. Certain things just aren't there because it's not a complete Linux platform. But generally, a lot of stuff works, and you can do, the performance is remarkably good. If you've written web apps that use the V8 JavaScript engine, you will know that the JavaScript performance is exceptional for an embedded device. And so, generally, stuff works well. The stuff to do in the future, there's a lot of APIs being developed now. So this is mainly in the context of this Webinos project: geolocation, device orientation, contacts, calendar, media capture, these kinds of things. There's some work being done on other device types. So we've got devices which are little sort of Android-enabled dongles with an HDMI connector that you can plug into your TV. So you can write, you can basically write a set-top box in Node.js, put it on one of these little sticks and plug it into the back of your TV. As I mentioned already, one of the things I plan to do is to migrate to 0.8. That's going to be a bit of upheaval with all of this isolate-related stuff. And hopefully from that point it will be easier for us to maintain it going forward. I mentioned there's no support for JIP. I'd like to do that so that there's a greater likelihood that native modules that you bring across will just rebuild naturally. At the moment there's no support for NPM. It doesn't make sense to put NPM on the device itself. I'm not going to port Git to Android. But there should be some better developer support for package management. So maybe you want to build a manifest, if you like, of all the modules your application needs on the PC, and then when you install stuff, then all of that stuff will get installed or synchronized. Also, dynamic Java modules. At the moment, there is an irony that I can dynamically download native shared libraries to the phone, dynamically open them, so I can dynamically deploy modules that are native code and open them and use them within a running Node instance. At the moment, I can't do that for Java because of some limitations with how class loaders work in Android. So that's something that I would like to enable, and it would be, the way things are working on the phone now. You've got Node is running as a service, so at any time I can deploy more modules. Just send it an intent, deploy some more modules. I can send it another intent to start a new Node instance. So I can run up servers, I can add functionality without restarting Node at all. And it would be nice to be able to include new sort of modules, new Java modules in that without having to rebuild stuff. And also, I'd really, really welcome input from other people. So this, as I said, this whole story is only just beginning. The platforms that we will see this technology deployed to is going to grow, it's going to explode, and there are millions of applications that no one has even thought of yet. So it would be great to get input on that. Okay, so I'm going to do a demo. And this is a very simple example of creating a JavaScript interface that accesses the geomagnetic and the motion sensor on the phone. So the first thing you have to do is you have to write an abstract declaration of the interface that you want. This is the interface you're going to want to call from JavaScript, and you declare that in Java because that's how we're going to implement it. So this has a very simple interface. I've got 4 methods. I can watch. This is based on the W3C orientation API, by the way. But I can ask for events when the orientation of the device changes, and I ask for events when the device moves. So I write a little abstract Java declaration of that interface. Then I have to implement it. So I write a class in Java that implements this iModule interface. This is the thing that's going to open the sensors, and then it has to have some code in that actually implements those methods I just declared. And now this is the JavaScript that is the server. So all it does is it loads the bridge module, and once it has it, then it loads the class that implements the API I just implemented. Once you have that, in this particular server, what I'm going to do is I'm going to open up a WebSocket server, and I'm just going to watch the orientation, and then when I get an event, I'm going to send just a single string with the orientation parameters, and that's it. So this server, I push to the phone, and then I should connect to it. So this is it. Now, I'm not so confident here because of the problem we had in the beginning, but hopefully this will work, and it doesn't work. So just give me 1 minute. How are we doing for time? Okay. Okay, great. So don't watch this bit. I didn't do this. Let's just restart things here. Hang on. Okay, let's just restart that. Safari, let's just try that. No, I don't believe you. Hang on a minute. Let's just try Chrome. Nope. This is, I don't know what's going on today. Hang on, is that it? No. Am I on the network? Yes. Safari. Server's there. Start. Oh dear. Well, never mind. If anyone wants to see it, come and grab me later. It does work. It's been working all day, and hang on a minute. Just one final try. Let's just kill it. It's not working. So, sorry about that. But that's it. Oh, finally, sorry. So I did say contributions are welcome. Everything's out on GitHub. The top project is Anode. That's the project that wraps Node. The Node fork is where all the sort of core porting of Node and the isolate stuff is done. There's a link there to Webinos. So the whole Webinos platform is on GitHub as well. You're very welcome to go and have a look at that. And the final link you can now ignore because that's the second demo I was going to do, but that didn't work either. Thank you.